Hello, good morning, students. Today we will study next part of this chapter, hydrocarbon. So second type of hydrocarbons are alkenes. These are carbon-carbon double bond containing compounds. The definition of alkene is alkenes are unsaturated hydrocarbons containing at least one carbon-carbon double bond. So alkenes with one carbon-carbon double bond and containing two hydrogen atom less than corresponding alkane. So alkene have general formula CnH2n, where this n is number of carbon atoms and n number starts from 2. That is, minimum 2 carbon atoms are present in carbon-carbon double bond containing compound. So n number may be 2, 3, 4, etc. We had already studied nomenclature of alkene. The first example of alkene is CH2 double bond CH2 is ethene. Second example is CH3 CH double bond CH2 is propene. Similarly, butane, pentene, hexene, heptane, octane. These are the different examples of alkene. The molecular formula of alkene can be obtained easily from corresponding alkane just by removing two hydrogen atoms from corresponding alkane. For example, we know the molecular formula of ethane is C2H6. If we remove two hydrogen, the molecular formula will be C2H4, and that is ethene. So like this we can obtain the different examples of alkene. Now we will study isomerism in alkene. First, what is isomerism? Isomerism means compounds having same molecular formula but different structural formulae are called isomers, and this phenomenon is known as isomerism. In alkene, there are two types of isomerism are observed. One is structural isomerism and other is geometrical isomerism. Remember these both types of isomerism very well: structural and geometrical isomerism. So the first type is structural isomerism, that is also called as a chain isomerism, because in this type of isomer the carbon chain nature is different, that is the structure is different. For example, if we consider the 4 carbon containing alkene is a butene having molecular formula C4H8, and the structural formula can be drawn like this: CH2 double bond CH single bond CH2 single bond CH3. Name of this alkene is but1-ene. Here the position of double bond between carbon 1 and carbon 2. Similarly, this is 4 carbon containing alkene is a butene. Here the position of double bond is between 2 and 3 carbon, and therefore name given as a but2-ene. One more isomer of this 4 carbon containing alkene is isobutene. Here one branch of carbon and carbon-carbon double bond is present between carbon number 1 and 2. IUPAC name can be given as 2-methyl-prop-1-ene. So the isomers of butene are but1-ene, but2-ene, and 2-methyl-prop-1-ene. These are three isomers possible. These are called as a structural or chain type of isomers. In the structure 1 and 3 along with 2 and 3, the examples of chain isomers, they differ in the carbon straight chain, and second and first, these are the position isomers because the position of double bond is different. I will explain again this. The structure 1 and structure 2 have same type of carbon chain, that is a straight. Only position of double bond is different. Therefore, this is called as a position isomers. And structure 1 and structure 3, or structure 2 and structure 3, these are chain isomers because in structure 1 straight chain, in structure 3 branch chain. Similarly, second structure is a straight chain and third structure is a branch chain. So 1 and 3 or 2 and 3, these are chain isomers. The second type of isomerism present in alkene is a geometrical isomerism. Now this geometrical isomerism is due to the difference in spatial arrangement of atoms or groups which are bonded to carbon-carbon double bond. That is, the arrangement in the space means arrangement of groups around carbon-carbon double bond is a different. That is called as a geometrical isomerism. Here we will consider the structure. In the A structure, carbon-carbon double bond, to the left side X and X groups are present, to the right side Y and Y groups are present. In short, similar groups on the one side of the double bond. And in the B structure, here X group is present. They are exactly opposite side of the double bond. Similarly, Y groups are also present on the opposite side of the double bond. So if similar groups are present on the same side of the double bond, called as a cis isomer, and if similar groups are present, they are present on the opposite side of the double bond, that is called as a trans isomer. Remember this well again. What is cis isomer? In cis isomer, similar groups are bonded to one side of the carbon-carbon double bond, and in trans isomer, similar groups are bonded to the opposite side of the double bond. That is, the geometrical isomers are two types. One is identical groups, or the similar groups are bonded or lie on the same side of the double bond, called as a cis isomer. And in the trans isomer, identical or the similar groups, they lie or bonded on the opposite side of the double bond, called as a trans isomer. Here is the example of cis and trans isomer. These are 4 carbon containing alkenes. Here carbon-carbon double bond at the center in both compounds. In first compound, CH3 groups, they are present at the right side of the double bond, that is to the same side, and hydrogen they are present again on the same side, called as a cis-2-butene, cis-but2-ene. Here 4 carbon containing long chain, similar groups are on the same side of the double bond. In the second example, it is a trans-but2-ene. Here CH3 groups are present on the opposite side of the double bond, and CHH, that is hydrogen hydrogen, these are also similar groups, identical groups present on the opposite side of the double bond. It is a trans isomer, can be named as trans-butene. Here, due to the difference in arrangement of the atoms or the groups in the space, these isomers differ in their physical properties like melting point, boiling point, and solubility. The geometrical or cis trans isomer of butene, they are represented here. So that is about the definition and isomerism in alkene. We had studied two types of isomerism: structural isomerism, in that chain and position isomerism, and second type is geometrical isomerism. Thank you.